At the moment, I'm quite busy doing big glasses of various designs, both with one-sided engravings and with engravings going all the way around. I call them 360s. So in this video, I will show you the theory behind engraving a perfect 360 using the LaserPecker 4 together with the rotary extension and the Design Space app. I will start by making a simple example demonstrating the concept of engraving a 360. Then I'll move on to show you how to create seamless engraving using overlap. And to round off, we'll have a look at seamless patterns. So, starting with the basics. This is the file I used to show you. 2 squares, one at each end of our pattern, and if all goes well, this is what the result will look like. This is my setup. I'm using glosses sprayed with tempera, and I'll engrave it at such low settings just to burn the paint away. Then I'll just repaint them for the next test. The demo file is an SVG file, so no cropping is required. And since I'm using the rotary, the graphic will be rotated 90 degrees in the app. Let's go straight into preview to review the relevant parameters. When engraving cylindrical objects using the rotary, you first enter the diameter of the object to get the correct proportions for your engraving. I've measured this glass and it's about 78 millimeters in diameter where the engraving will be, and the app will then calculate the perimeter. By entering that number as height, we are good to go. That looks nice. Let's try again a bit higher up on the glass. Just remember, since the graphic is being rotated 90 degrees, height in the app will be how wide the engraving will be on the glass. The reason this works is because as long as perimeter equals height, the glass will be rotated exactly 1 lap. It is important that your measurement is as close as possible, else the proportion of the image will be off. That looks nice. Next up is overlapping. This is the chain I've been using on some of my beer glasses. But adding the last link overlap with the first, an impression of seamlessness is created. Using a pattern with width equal to the perimeter of the glass, I calculate the overlap to be 2.5 millimeters. Now to repeat what we did just earlier, running this one as black and white, I'll be adjusting the diameter to a more precise value of 76 millimeter. And as height, we'll enter the sum of our perimeter and our 2.5 millimeter overlap. This doesn't look quite right. The overlap is as it should, but it seems that we have some cropping issues. I'll have to look into why, but I'll leave it in here as it's still a good example of overlapping and also shows the importance of testing, evaluating, and if necessary, repeating. Moving on to seamless patterns. As you have seen, the technical part is not that complicated. Most of the job is getting a proper graphic to work with, and that goes for seamless patterns also. This design is one I downloaded from the net, And as you can see, it is seamless in both directions, but we just need it to be so horizontally. So I vectorized this image in Illustrator and moved this bottom part to the top to fill in the pattern. Then I copied and pasted them side by side to get the size I wanted. And by looking at the seam, we can see that they flow well into one another. So let's run it. As in our first test, this is a SVG file rotated 90 degrees. The diameter of the glass is 78 millimeters. We'll enter the perimeter as height. And let's mark the seam to see how well it goes. Now this is an actual engraving, and for these IKEA glasses sprayed with tempera, I use 100:1:1 for SVG. For black and white settings, I use either 2K 100:10:1 or 4K 100:1:1. Now this looks really promising. I'll quickly take it inside and rinse it off, and let's have a look. And I'd say it's perfect. For more information or tips on how to create seamless patterns, simply Google seamless patterns or how to create seamless patterns. Now that you know how it works, give it a try. Just make sure your graphics are okay, and the rest will follow.